Somehow the due date for lab 9 got set to Friday for some reason. So nobody expected that, right? So you all turned it in on time? You all turned it in last night? You just waited? Yeah, I think I'm gonna reset that back. I don't know why that, you know, probably last year I changed it. But hopefully that went okay. Any questions, any issues with lab 9? Okay. I'm having this unsettling feeling that, you know, when I say at the beginning of the semester, yeah, you can just take the class online and stuff, 2/3 of them disappear. And then I'm not getting a lot of work turned in. And I find what's interesting is a lot of people just like, they'll be here for the lecture and then they'll just like leave as soon as lecture's over. So there goes another opportunity to get a lab finished. Maybe that's just people's priorities, but I don't know. Maybe I should take out that, maybe I just make everybody stuff everybody in here and not post my lectures, right? Maybe that would be better. What do you think?
The lectures kind of work counterpart with the homework.
Yeah. Gets you ready. Yeah, no, it's good. And online people, if you're listening, yeah, if you there's plenty of room here. If you want to come in. The computers are failing. That could be. But if I, you know, if we did a structured like pair programming for the labs, then there's automatically enough computers because you only need half the number of computers. Just don't have enough chairs. We could work on that. Some people have laptops, you know. Paired chairs. Yeah. 2 people, 1 chair. You'll probably learn a lot more that way. Today we're going to look at dictionaries, yet another data structure, and Java calls them maps. So there's like a hash map and a tree map. Those are 2 classes that implement the map interface. We're calling it dictionary. Nobody uses a dictionary anymore, but I guess, do you? Do you know what a dictionary is? Does anybody know what a dictionary is? What is it? Okay, words indefinite. Okay, they still teach you that? Good. Why do you need a dictionary anymore when you have Google? Yeah. Table, it's like a table of information. And it's also called an associative data type because you're associating one thing to another. Same idea as map. A map is sort of has many meanings, but one meaning of map is to connect, you know, it's sort of a connection, it's sort of a mathematical concept of map is to connect like one space to another space. You're mapping, like a function maps a value on the x-axis to a value on the y-axis, right? So a map can kind of transfer from one to the other. And so, you know, you can use this map structure to have what's called keys and values. So if you're making a dictionary of words, the word itself would be the key, and the value, you look up the value by submitting it to the dictionary, and it returns the value for you as the definition of the word. Yeah, it's 1-to-1. It's a 1-to-1 mapping. But it can store objects. Yeah. Yeah, there's a lot of ways of using maps. This is dictionaries. This is the data structure that you would be using if you do the evil hangman program for the final project, the evil hangman, where the key would be some representation of the pattern that the guessed letter makes in a word. So like if the person guesses E and you have the word hello, the pattern of E in the word hello would be like dash E dash dash dash, right? And that can be how you look up all the words that have that pattern, you know. So that's kind of the cool thing about dictionaries. And I just told you the secret. But you don't know enough yet, so I don't think it matters until you've started it. Yeah. I haven't gone into MS config and mess with a register. Like a what? Yeah, I don't know. Yeah, there's a lot of interesting things, but let's start by playing around with a real dictionary. Let's download the link for the lab. Oops. So grab that lab 10 download. Go ahead and pull that up. We're going to do lab 10A. What's this telephone directory? Telephone directory is another use of dictionary, but I think I have one in here already. While that's loading, you can kind of get a picture. Yeah, here's a dictionary, right? And here's a definition of the word. The key is the word, and the definition comes after. And essentially, what the data structure looks like is you are linking up a number of search keys with the corresponding value that goes with that key. And it's one-to-one. Each search key has a single corresponding value. Although it's possible that multiple search keys could have the same corresponding value, it's usually you're just kind of having unique search keys and unique corresponding values. So having extracted that and open up BlueJ, try compiling. What's this teamwork thing? Oh, that's weird. Is that a new feature in BlueJ? Or did this just pop open somehow? Oh, I must have accidentally hit that. Has anyone tried teamworking in BlueJ yet? Huh. I'll have to play around with that. That is cool, huh? Does a lot more than I remembered. So here is a sorted array dictionary. Oh, this is a pre-compiled one. Here is the test driver for that. And this dictionary thing we're going to create an empty dictionary that will contain the names of friends and phone numbers of friends. So that's those here. Yeah, names and telephone numbers of friends. And we're going to use this sorted array dictionary class. So we're going to say, all right, let's make a sorted array dictionary. And here's the cool thing too, use different data types for the key and the value. So they don't have to be the same. We have to specify two data types though, one for the key and one for the value. So this is going to be a new sorted array dictionary. Like that. And we're just going to add a few names. So we're going to say, all right, phone book dot add. And what happens when you add an entry to a phone book, you have to give it a key and a value. The key is going to be what you're going to use to look up the value. And in this case, the key would be like the name of somebody. And since we're storing the phone numbers as strings, we'll just write them out hyphenated or whatever. Something like this, just add a bunch of names and phone numbers. Maybe one more. I guess we're supposed to have a Steve in here. Let's do that. And there is a display method. We'll talk about how, well, let's see what we're supposed to be here. We're going to print on display. Yeah, so to print the entire phone book, we have to make an iterator. So in order to pull these things out, like there may be a toString, but I don't know, that would be kind of complicated. There's basically two parallel tracks of data going in this data structure, right? And each one of them can have its own iterator. One of them is called a key iterator, and the other one's called a value iterator. So we get an iterator for both of those things, and we can kind of we call that traverse the two sequences of data. So to print it, we're going to have to get an iterator. So we're going to get an iterator of string, and this is going to be our key iterator. So that's going to get an iterator over all of the keys, and that's going to be in this case, the keys are the names, right? So here's our case. That's a little mysterious. The key is the name and the value is the phone number. And anything you want to associate, you don't have to do phones. It can be account names and account numbers. It could be another final product option is to completely represent every possible move in the game of tic-tac-toe with a dictionary. And the key would be the sequence of 9 characters, O's and X's and maybe blanks. If you just put them in a line instead of like in a table, it would be all of the possible board configurations of tic-tac-toe, of which there's like, I don't know, it's a lot. It'd be a very big dictionary, right? And you could come up with the best move for each possible move, and then it's all pre-loaded, and then the game could play, without any much thought. It could just take whatever move is whatever current board state is being presented, and then come up with a new move based on that. And the move would be the value, be the instructions that come out for this particular board state, right? So there's a lot of ways of associating things together, and so dictionaries find a lot of uses in modern applications. So we'll make a value iterator that goes over all the values. And this is just something that we can traverse. So we can make a loop that says while the key iterator has next. That's not good. So we just say, there must be something weird. No, it's very strange here. System. All right. So we're just going to say, okay, we're going to print out the key iterator dot next. And value iterator dot next. So when you get to that point, you can run this and you can see if it actually prints out all those phone numbers. Let's do that real fast. And there they are. Okay, what else do phone books have? Well, there's a contains method. They're very similar to lists, but they have a few extra features. If Steve is in the dictionary, we'll display the phone number for Steve. So we'll say if phone book dot contains Steve, no surprise. So if the key is there, then we're going to print Steve's number. And so there's another method called getValue that takes a key. So you give it Steve, it spits back the phone number for Steve. And another thing you can do is you can update with a new phone number. So like suppose Steve's number changes, you can say, you can add a new number, phonebook.add. You can add Steve a second time. And Steve's new number is different, so we're able to replace that. And what the add method does is if it finds the key already in there, it goes and just changes the value to the new value. And it also returns the old value. So you could actually, if you want to, you could say something like string old num equals phonebook.add, and then so the old num gets the current value, well, previous value or whatever. Hey, Nancy. So these are things you can do with phone books. And print the entire phone book again. We could just copy this code. Well, actually, no, there's another method to help us do that. There's a better method. There is a method called display. We can also print the old number for Steve, system out, print line, Steve's old number. And then to invoke display on the phone book is another way to print out the entire contents. And you can see the new dictionary has the new number for Steve in there. And the old number comes out from the get value method, or from the add method. And finally, there is this pretty extensive test dictionary method that will go through and make a more complicated phone book with more phone numbers. You can see how that's all working. It's, in case, here it's called a name list, but same idea. And we are creating all these phone numbers in there, printing them all out, checking if these numbers are in there. These people are in there. The remove method, you can also remove items from the dictionary, and the remove method will return null if the item was not in there. So you can kick that off if you want to explore that. Just activate this line here that says test dictionary. So anyway, a lot of stuff there, but it's basically working okay, and shows you all the other features of the dictionary. So that's the dictionary, and We are going to create one, a very simplified dictionary, just to show you how those are actually constructed. And these are the methods that we'll be giving it. There's this add method, remove method. You can get the value for a key. You can get an iterator for either the key or the value. You can see if the dictionary contains the key. You can also wipe everything out if you want to. There's different choices on how you deal with keys. You have duplicate entries or not. If you do have duplicate search keys, then it becomes more complicated to remove items, because then you want to search for all of the ones that have that. So there's just some design choices. The Java, again, Java calls it the map. So let's actually just check that out real fast. It might be interesting to see if there's any differences. You can check out the Java map interface. Pretty similar, has it contains. Actually, I guess it's called, no, it's a map. So there's also a set interface. Or is a set? No, there's a set and a map. Yeah, a map is different than set. Set only contains the values. It doesn't have, or keys, it doesn't have values that go with it. It's not associative. Oh yeah, but you can get a set. Oh, I see. You can get a set of the mappings contained. That's interesting. Put them all in a single vector. Do you use those? Yeah. Yeah. Yeah, we're going to talk about hashing on Wednesday. The add method is called put. Slight difference. And so it doesn't look like it has an iterator method though, right? Is it actually just returning, it looks like it's returning a set of the keys and a set of the values, which I guess would take the place of the iterator. The set is backed by the map, so changes to the map are reflected in the set and vice versa. So you get the set and then you get an iterator from the set maybe. Or maybe it actually is, it's got it from a superclass. Yeah, anyway, that is the hash map. So, is there anything else worth looking at in here? We're going to set up these parallel structures. Here's kind of what it looks like for a dictionary of telephone numbers. And this dictionary is associating each name with a particular string. And let's just, yeah, in the lab, the really cool activity you're going to get to do is you're going to keep track of the word frequency for all the words in chapter 1 of Moby Dick, which is a really fun activity. So if you open up the Lab 10 folder, there's a Moby Dick chapter 1, which starts, as you know, with call me Ishmael. And what we're going to do is we're going to keep track of, this is actually not wrapping, so this is the whole chapter 1. Fairly lengthy, several pages. And what we're going to do is a word frequency is going to tabulate the count of all the words in the dictionary. And first of all, it's going to lowercase everything and remove all punctuation marks so those don't screw up the reading of words. Because if you read, if you read Ishmael with a period after it as a different word than Ishmael without a period after it, that screws up your word frequency count. So you can get rid of all of those punctuation marks by reading it a certain way. And then we can keep track of the count in a dictionary where the key is the word and the count is going to be an integer representing how many times we've seen that word in the text so far. And every time we see it again, we add 1 to the count. If it's the first time we see it, we make a new entry. But first, we have to get an inside view of how these things actually work. So we're going to go over to the easy dictionary class and construct a simple dictionary. It's not going to be a sorted array dictionary. It's just going to be a plain old kind of unsorted. So what we're going to use to create the easy dictionary is going to be a vector of keys and a vector of values. We've got the iterator up here. We'll also add the Java util vector class. So we make a private vector, lowercase, capital, private capital V vector of k keys. K being the generic type for the keys, and we'll make another private vector of V for values. So we can also make a constructor. So we'll make a I think we don't put the data types here. I'll just do that. And in this case, keys is going to be a new vector of k values, a new vector of v. So it's pretty simple to add an item to the dictionary. The first thing we want to do is we want to see if it's in there, right? So we can check to see if keys dot contains the actual key of interest. So in other words, oops, I got that the wrong way. It's keys dot contains. So keys is our vector. If keys contains the key, this is the key that we're actually trying to add and the value that goes with it. If this key is already in the keys vector, then we first want to find the location of where that key is. So we're going to say keys dot index of key. So luckily the vector class has an index of method that tells you where in the vector something is found. So we can use that to look up where the key is in that vector. And then we want to go to that same location in the value vector and save that. So we're going to say v temp, because we're going to return this when we're finished, values.get of location, right? So we get the values that goes with the key, the value that goes with the key. And we're going to store that in temp. That's our old value that we're going to return later. And then what we're going to do is we're going to change the new value. So we're going to change that location, values.set, to the new value at that particular location. We'll say so location and value. And when we finish, we'll return temp. That's the old value that we're returning. And then if it's not in there, then we're just going to add this to the end of the keys vector, this key to the end of the keys vector, and we'll add the value, values.add value. We'll add that value to the end of the values vector. And by returning null, we indicate that there was no prior value for this key in the dictionary. So there's nothing to return. Anthony? Oh, we don't need the else? Yeah, I mean, it's kind of a stylistic thing, right? You're saying, you mean just get rid of this? Mm-hmm.
But if it's not true, it's not going to run that program.
Wait, say that again? Uh-huh. Right. Oh, yeah. So how do you stop? So how do you do it? Because you're returning, then you're saying you don't need an else there. So would you just do it like this then? How would you do it?
Yeah.
You would do it like that. Is that something that you just lashed on yourself, or do you see other coders doing it that way?
I see a lot of people do that now.
It probably doesn't speed things. I don't think it speeds anything up. I think there's a little bit of, if you don't have that else there, then yeah, I guess either way, it's probably fine. I kind of like it because you're kind of dividing up. Okay, it's either going to have it or not. Let's put this in a little container, put this in a little container, and we'll keep them organized that way. Kind of a stylistic choice, I guess. Yeah. Okay, what about remove? This is going to remove the specific entry from the dictionary. And so, and it's either going to return the value that was associated with the search key or null. Again, it's going to be pretty similar. We can copy the same structure, if you're cool with that, as we had from the add method. Let's just do that. Let's just copy that whole method and paste that in here, because we still have to look up the location. And either the thing is in there or not. If it's in there, then we got to find the location, right? And we got to get the value there because that's what we're going to return because we're removing it. But instead of setting the location to some new value, there isn't a new value, so we're not going to do that. What we're going to do is we're going to say values dot, and what is it remove? Values dot remove. And we can remove the value at that location, and we can remove the key at that location. And return temp when we're finished. And if it's not in there, then we just return null. So we're starting to build data structures out of other data structures, which is pretty cool, right? So we can actually, I mean, last week we decided we'd created a sorted list out of by inheriting all the code for a regular list. We're making this dictionary out of existing vector classes. Just makes it real easy. As we go further, like this extra credit lab at the end, if you want to do that that graph class, that's a super class that has pretty much, it's got stacks and queues and lists and a whole bunch of stuff in there that it's managing a graph, which is how you connect like 2 points in space, or a network, a kind of a generalized network. You can create that in software as well. So we're able to use the values that, or the methods that these classes already provide for us, which is nice. The get value method, though, is pretty simple because that's going to, well, very similarly, how do we get the value of a key? What are we going to do to get the value of a key? Pretty much the same thing that we did here. In fact, it's pretty much just like the remove method, only we just don't remove anything. So you can copy that in here and just delete the 2 calls to remove. What about contains? One liner, right? Contains is going to return keys dot contains key, right? Spell contains right. Well, we have a get key iterator, so for get key iterator, we're just going to return keys dot iterator. The vector has its own iterator. I think it's just a lowercase I, sorry. The vector class has its own iterator method, so we can get an iterator from that. And is empty is going to return, very good, keys dot is empty. Get size can return keys dot size. Clear would be likely to clear both the keys and the values vectors. Sorry? Yeah, you want to do both. Okay, so now we're ready to try this thing out. What if we, instead of making our this a sorted array dictionary, let's just make this an easy dictionary for our test driver. Easy underscore. Easy underscore. And we can just make sure that it's running okay. Oops, I got an error. Oh, I guess our display phone book call won't accept an easy dictionary. However, yeah, and I think, well, we could overload this, right? Let me do that. Let me just make a new version of display. That takes an easy dictionary. And everybody's happy. Did I go too fast? Does anybody want to see anything from back a little ways? And this is our original dictionary at the top. So you can see it works pretty much the same way. So they definitely have a lot more. I found out later that Career requires students to generate a project for each of their spring classes, so they can do a project. Question?
Remember another reason why string is final for immutable is because the hash code that when object opens up the hash code, if you were to make a string completely different, the same syntax concept like Bob, and then create a new string called Bob, have different hash codes. Rather than if you were to be immutable, it would be the same hash. It would be the same hash code.
You're saying two strings named Bob would have different hash codes, but why wouldn't, no, they
were not, if it were immutable, as it is now,
No, I think the definition of hash code says that if two objects are considered equal, then they must have the same hash code. I don't know. For number 3, which one are you looking at? In this part A, number 3? Oh yeah, we use vectors. Yeah, we're done. We did number 3. So we did the first 3 together. So now basically you're doing step 5. And those things that say optional, I keep meaning to get rid of the word optional because then people don't do it. I don't get that. No, I don't believe in extra credit. It's just that, yeah. I have to keep changing stuff. So this is the Moby Dick problem, and it's really cool. First of all, there's a new way of reading things that we have to figure out, and because we also read this file name, and we're making this scanner that associates to that file name. And then there's a special way of reading stuff that allows us to skip reading blanks and punctuation marks from the file, so we can read only the words. You know, which is pretty cool. I don't know why it's that weird symbol. It must be some kind of regular expression. Yeah, very necessary if you're doing any text processing. But they're kind of cryptic. Did you figure them out? Yeah, it takes a while to kind of get used to what they all mean. It'd be a while to explain it. Yeah, it's kind of cool to work that into this class too. And then what you can do is you read the whole file, and this one is showing you how you can read it and convert everything to lowercase. So if you run this now, it prints out every single word in sequence in the whole chapter. And notice it's all converted to lowercase, no punctuation marks. So Ishmael at the beginning of a sentence will be the same as Ishmael at the end, or words that were capitalized, whatever, are going to not be, have that same. They're all going to be the same keel. So we're going to try to tabulate all those, right? And so what we're going to do is, and now that you see that that works, you can comment this out, putting 2 slashes here. The idea of this, and it's a little bit hard perhaps to visualize, but think about it as a picture. Let me draw a picture here. I think that will help. So the picture says, when you're reading a word, so here's our pencil here. Let's do that. Here's our keys and values. And the idea is, suppose we read the new word, make this fatter. Suppose our new word was and, right? That's going to show up a lot in this text, right? And it turns out we have the word and in here already, and it's already showed up 3 times. So we have to make a change to this data structure so that we want to make that 3 say 4, right? To take care of the fact that we just read another version of and. So how do we do that? Well, the dictionary has these methods, right, that allow you to retrieve stuff, So any thoughts what we might do? Yeah. Change the value. Yeah. Sorry. Yeah. So and is the key, and the value is the and we're calling this, by the way, the frequency. Oops, the word frequency. I don't know. I would might have called it count, but the typical thing is to call that a frequency. I think if you're doing this kind of analysis, it's how many times it's occurred. So you can pull this value out. In order to make this 3 of 4, right, you have to extract the value. You have to do a get value operation to get the value that goes with that key, right? Once you have the value, you have to add 1 to it, and then you have to add and the new value back into the dictionary so that it's been updated properly, right? And the way the and method works, as we saw, if it's already in there, it just, returns the old value and updates it with the new value. It doesn't make a new entry. If it's not in there, then you have to make a new entry the first time. And so the word like boom, it hasn't showed up yet, you're going to add that at the end automatically, boom, not bool, with a frequency of 1. The first time the word is not in the dictionary, you add it to the dictionary with a frequency of 1. If it is in the dictionary, you got to retrieve the frequency, and then you got to add 1 to it and add it back in. This shouldn't really take too long. Those 6 and 7 are no longer optional. I have to get rid of that. I'm going to redo that right now, so anybody who pulls this up later will not see that. Because this is where it's interesting. You can, first of all, this is the first one is easy. Number 6 is very easy. You can add a get method, a get key method. Let's pull that thing up real fast. So the get key method is going to take a value and return the key associated with that particular value. So add that to the easy dictionary class. And then this one is, you ready, Salon? This other one is to modify the dictionary class that you just created to maintain either the keys or the values in sorted order. The thing is, after you solve the Moby Dick problem, if you use a sorted array dictionary, the dictionary is going to be displaying in terms of alphabetical, in terms of the word, which actually kind of makes sense. You can see, and it'll have Bravo and Charlie, all that stuff in order with the word counts or frequencies for each of those words. But sometimes it's more interesting to display the list in terms of like decreasing word frequencies. Like you might want to know which word appeared most frequently. You want that to show up first. You want it sort of reverse sorted by frequency, right? And that's what number 7 is talking about. If you modify the easy dictionary, you can add a parameter to the constructor so that you can indicate how you want it sorted, and you can sort it by, like say, ascending keys or descending values. And the add method would have to use sequential search to locate the position to insert an item because well, I guess we could use binary search. Although I think that isn't going to work too well. I think we have to. Yeah. Anyway, this obviously is under construction, but I would recommend this. It's really fun. People have done that. It's a really cool project to try to kind of dig into this data structure a little more than just kind of this cursory thing we've just done today. But try to make it so that you can display the word list in descending frequency order when you're all finished. So the word that appears most frequently will be at the top, and then you'll have a bunch of words at the bottom that are all just showing up once. Yeah. Yeah, that's your challenge. You ready for it, right? Yeah. Good challenge. Yeah, you know, you could. Let me just pull something up real fast because I didn't really look at this. There is a whole bunch of options for dictionary implementations that I was supposed to talk about. So you could, if you wanted to, like what you were just saying, is you could put both the key and the value in a particular object instead of having parallel vectors. Here's an example of what that would look like, right? You could do that if you find that easier. You want to modify the Easy Dictionary to work that way. I'm not sure that would really help you in terms of, I guess it would keep them tied up so you don't have to worry about them getting scrambled, right? Yeah. Yeah. That's a good idea. Yeah, that's a really good idea. So Anthony says, yeah, that would allow you to sort it and not have to worry about things getting misplaced, right? So if you do want to do it, you might think about changing the whole structure of that to use like an entry class to store an entry for the dictionary, and the entry has both the key and the value tied together, as opposed to how we did it right here. This has a little bit more memory overhead, I guess, you know, but I think the trade-off is probably minimal. It's kind of showing you how to do the removal if you're doing it without a vector class. It's kind of showing you the big O of these guys. And if you are going to make it sorted, then you have to make sure everything is comparable. All that shifting has to be done. If you're using the vector class, though, I think you can still kind of modify the vector approach and make it work properly. There's a vector implementation and a linked implementation too. I've got to figure a better way to convey this, but when you're ready, you could think about how to make the easy dictionary itself be able to keep things in a sorted order. Now we're using a vector to store the items, so it's not really convenient to using binary search, because binary search works on arrays. If you want to do a binary search, you could dump the vectors into an array using toArray and then do a binary search on that. But maybe that's a lot of headache too, because that's an O of n process that you're going to be then doing, you know, it kind of kills the whole log n thing anyway. So what if we did a sequential search to look for the point where we should insert the new item, right? And a sequential search is pretty easy. You just keep looking at the first item, and if everything's in order, you know, just advance one. Sequential search is O of n, which is not crazy good, but you know, so what? And you just keep looking at the next and next until you get to one that exceeds the value that you're trying to find a place for it, and then that's the point where you're going to insert it into the vector, right? So the way that would work is that door locked? I guess it was open. Should I unlock that? I should probably. Is there anybody else out there? Well, I'll do it. I don't want floor. So if you want to sort this thing, what you would want to do, of course, first of all, you have to indicate that, you know, and you want to be able to sort it by key or by vector. Then both K and V should be extending comparable. And you got to say comparable of space question mark super K, right? And the same thing with V, extends comparable of question mark super V. Two of those guys there, right? That's a lot of big mouthful, right? And you can come back and look at this later if you're still doing the regular thing, because this might screw up your this will screw up your dictionary for a while until you get it all working again. So I don't necessarily recommend that you all follow this, but if you've already finished the main number 5, the word frequency one, I can take you this way. But yeah, is anyone still kind of drawing a blank on how to do the word count one? It's a little, I wonder if I should go into that first. What do you think? Anyone need more hints on this one? So this one is just a read. And you can make it lowercase. You do that all in one line, right? So this one is just a one-liner, right? This is basically what I mean by this is use the use get value, and we want to make an integer frequency because that's the type of object that's going to go inside a value. That becomes a value, and it's an object because this. See, we're using a capital I integer and string integer value key pair for a word table. That integer is indicate how many times the word has appeared so far. So we use the get value method to look up the frequency of next word. And there's two options. If the frequency can be null, that means it wasn't in there. Then you're going to add next word is a new entry to the word table with a frequency of 1, right? It's the first time you saw it, right? Otherwise, you want to update next word in the word table with a new frequency of 1 greater than the current value. So that's another add, right? Without spelling it out too much, it's not too challenging. Once you wrap your head around what's going on, it's not too bad. So whatever frequency is, frequency plus 1 is going to be 1 bigger, indicating that you saw it again. It's going to replace the old value with the new value that's 1 bigger. Every time you do that, you're going to end up having a much increased dictionary, indicating all the times the different words showed up. But what about if you want to now sort this thing? Any questions before I leave Moby Dick behind? Is it too early? Are you guys ready for this? If you want to keep your dictionary sorted, just like we did from that old compare to exercise thing, you might want to make a variable for the sort type, in which case you would have a ascending keys, which is maybe 1, or descending values. Those might be 2 different ways you want to maintain your list. Now the thing is, I think you can only create that you can only set the sort type when you create the object, so you shouldn't really change the sorting type. I think maybe you could, but that might cause some issues if you all of a sudden decide, oh, I'm going to sort it the other way now. Should use an enum. I should. I'm doing so many bad things. And the sort type. And when you create this, you can say int sort type. Maybe call it new sort type, or yeah, we'll just do that. And we'll say this dot sort type equals sort type. So when you create your dictionary, you got to indicate what kind of what way you're going to keep things sorted. Then we can think about how the add method has to work. And probably, I should set this up as an inheritance thing again too, because we're gonna butcher all this code that already works just fine. I hate doing that. It's too late. Yeah, you could always refactor it. Yeah. So the add method now. What I kind of had advised before is you could check to see if the keys contains that key, and then based on the sort type, if it's ascending keys, let me see. There's a little bit of a difference about how you would actually have to do this, whether it's ascending keys. If you're sorting by values, it's a little more complicated. But if you're sorting by keys, that's kind of straightforward. And in this case, we would check, if keys contains key, and the sort type is ascending keys. Oh, I'm screwing you guys up. It works, but it's going to destroy. You're going to be really confused for a while. Maybe you should just do undo and undo it all. Go back to normal. Let's do that. because I don't want to destroy what you've already got. Let's undo everything. I'm going to start over. And what we should do is we should inherit a new version of this thing. Get rid of all that stuff. Get rid of sort type. Because really, it could be days before you get it working again. You have something working, and you don't want to screw with something that works, right? So what we should do, this is the right way to do it. Sort of thinking out loud. Sorry about that. We're going to make a new class for easy. We'll call it this easy sorted dictionary. And this is where we do all that other stuff, right? We'll just override the add method and the yeah, you might have to add other things. So yeah, maybe this is extra credit. Maybe it's optional. Darn it, I want to make this required, but maybe not this semester. Yeah, but that's cheating. You dumped all of the stuff into, I want to get the dictionary to maintain it and sort, just like the sorted array list dictionary does, right? Sorry, I didn't mean to accuse you of cheating. Yeah, each time he wants to extract it, he would have to resort it. Yeah, it's not the most efficient. Yeah. So following the letter of the law. Okay. Yeah, you're totally legitimate. But it's not the solution I was looking for. The more elegant one, right, is going to be where you're going to, oops, question mark, super, lowercase s, super V. Did you all do that so you didn't destroy? You basically saved your working easy dictionary class, right? I hope you did. I'm doing this for your sake. This is why I use version control. So it's that, but it also is going to extends easy dictionary. Of KV. Okay, so no matter how bad things get in this class, you can always go back to the easy dictionary. True? And we're just going to add this field now. We're going to add the public static final int ascending. Oh, let's do it. Should I do an enum? Can you talk me through the syntax? I haven't done enums in a long time. Don't you have to define that externally? Or wait, you can just find it right here. You have to. Can you create a private enum right here? Okay, this is audience participation time, so it's private enum sort type, and then it's like that. Curly brace. Okay, but then do I just list the values or no? So then we say ascending keys and descending values. And what enum does is it assigns 0 to the first one, 1 to the second one. It's just automatically assigning. Yeah, so it's the same thing that we were just typing, only it's.
the value by default.
Mm-hmm.
It's not assigned an actual.
The values don't really matter that much. They can be arbitrary. It's just the names that we want to keep track of, and it just assigns an arbitrary number to each name. And these are not in quotation marks. These are like literals now that you can use in your code. And so our constructor would say int. So these are the possible values, but then we also need the actual variable, right? So how do we make a variable that's going to hold that? Is it just an integer? Private int, it's an integer though, right?
No, it's not.
Do we have to say, oh, private sort type? Okay.
Yeah.
This is a new type. Should I use capital S then? I probably should. Capital S because all types are capitalized, right? And then just use lowercase sort type.
Yeah.
So we're taking a sort type, and we're going to just say this dot. Yeah, whoops.
And maybe sort of public static so everyone.
Oh, you're right. Public static enum, thank you. And we are just going to say this dot sort type equals sort type. Maybe it should be not so easy sorted dictionary. A little optimistic here. It is? I'm getting issue with the enum here. What's Anthony, what's my issue here with the enum? Oh, I need an underscore, thank you. Okay, that's better. Okay, you're missing out. And Tony, what is yours? What's it saying? Did you do all this stuff? Did you put make sure to change this to V so it's super V like that? Yeah, that should just be, that should just be played from yeah.
No extending off.
Not yet, no, because that one doesn't care.
Okay.
Yeah, so Tony's problem was he had, oh, I still have mine too. I didn't get rid of mine, that's why. But somehow it accepts it for mine. Make sure it's just good old, each dictionary should just be good old KV. We don't care whether they're comparable or not. Somehow mine didn't flag that. Yes, and sorry? Do you have to make getters to get the vectors out? No, let's just make it, that's a good question. I was thinking about that. Let's just make them public or protected. We're winging it, true. Did you get it working, Tony?
Yeah, I think it's a lot of work. I think they even
It should be like this. This is what I intended. It should be back to its normal. This is how it was working. Because we're not sorting anything in the easy dictionary, so they don't have to be comparable or not. It doesn't matter. But here, see, we're going to, we want them to be comparable. And I'm kind of interested because we didn't really import comparable yet, and that's, but anyway, apparently it's picking it up some more. Okay, so far so good. And then, oh, I also, before we forget, I also made these protected back in the original easy dictionary. That means we can access those in our inherited class. Yeah. So change it from private to protected. So we're going to set the sort type, but we're also going to call super to invoke the constructor of the parent class in our sorted dictionary constructor. Okay, now we can go back to the add method. Let's get rid of all this. So the add method is going to return a v, and it's going to be add, and it's going to take a k key and a v value. This is going to be an override. I could do at override. I could do that like that. Very cool. An O, capital, good. 2 R's, override, like, okay. Capital O, override, thank you. Okay. So let's start with the add method that we had before. Let's just bring that over to our new class. And now we're going to check to see if keys.contains key. Because there's going to be 2 different ways of dealing with this, right? So if our sort type is ascending keys, that's pretty easy. So we're going to say, okay, and, oops, get rid of that. So if keys contains key and, oops, and the sort type is ascending keys, for an enum, wait, did I do that? Did I do that wrong? Can I not say equals equals? Oh, so that's because it's an enum. Oh, that's annoying, right? So I got to say sort type dot ascending keys. All right. Thank you. Okay, so we get the same location as before. This is easy. We're just going to replace it, right? We're not going to change the ordering of anything, right? That's the beauty. It's already ordered, so don't mess with it. We're going to get the old location, the old value at that location, and then we're going to set the location to the new value and return temp. Nothing really changes. That's it, right? Then there is this other option though, and this is where things get a little tricky, because if you're trying to keep things sorted by value, that's weird, right? Because when a new word shows up, all of a sudden the order has to change. So when you have it by values, you've got to actually remove the old key value pair and then reinsert the new value so it can go in the right location, right? It's got to figure out where that's going to go, right? So this is how this has to work. You've got to say, again, this is going to be, it's in there already, right? It's in there, keys contains key, but now the sort type is sort type descending values. So we've got to go find that location. So actually we have to copy all this stuff pretty much. Let's do that. We got to get the index of the key. We want to get that old value. But now what we want to do is, instead of setting it to a new value, we want to actually remove the key, which will remove the associated value. We take that whole thing out of the dictionary so that we can then add the new one back. We can add it back with the new value. So now we're going to invoke add of key value, where we add back as a new pair, right? Because the key's not going to be in there anymore. We just removed it. Does that make sense? It's kind of abstract. Think through what I'm talking about here. And I guess, would you like a picture? Would that help? Would you like to see a picture of what we're doing? So let's imagine, actually, let's just do it in Notepad. So here's the thing. Maybe you've got, we're doing it in descending. So maybe, and shows up quite a lot, right? Maybe there's 300 ands. And then there's the word the shows up 150 times. And yeah. And then there's, what's another common word? A. Something like that, right? This is your list so far. That's probably enough, right? What else? Me? 26, good. And so suppose we're trying to add, like another A showed up, right? And so we're trying to add this pair A and 55, right? Another A showed up. So we have one more A, and there might be another thing named with 54 times, maybe all, right? And actually, let's just do this. Let's do this would be even better. All, we're adding all, and A showed up first because it's sort of alphabetical. I don't know if that would do, actually it probably doesn't matter. Probably doesn't matter. Okay, suppose we have A and all, both at 54, and we're adding a new all, right? We found another all. And that's going to change the order, right? It has to put the all in front of the A because it now has a higher count, right? So it has to put that in a new place. So what we do is if it shows up, right, if all is in here, and it is, it removes that whole thing from the list so it can add it again and find out where it belongs with this new count, right? And so it's going to add that in front of the A like that. Does that help? Acting things out? Well, we check out where the original location was, and we remove it, and then we add it again. But the adding has to be done now where it looks for the place where it belongs, right? And that's what the last block does. So, so we're still doing that. Yeah, now we're going to do the final else block, and this is where it gets kind of interesting. If it hasn't been interesting already. So in this case, we're going to punt and we're going to use another method called find location, because this will be nice because it'll be generalized. It doesn't really matter what type we're doing. So we're going to say location equals find location of key and value. We want to find out where that thing should actually go. And then we're just going to add to that location a key. Wait, what? Oh yeah, we're going to add the key to that location in the keys, and we're going to add the value. Values.add the same location, the value. And we will return null because there was no other item there to begin with. So this is going to put it in the right location. So this else block is what we're doing is we're adding a new key value pair at the correct location. Find location, why does it also need a value? Wait, which? Key and value, right? Well, because find location is going to work whether you're sorting by keys or values. So we'll just give them both. Then the method has everything it possibly needs, right? And we're getting an error because we don't have a find location method yet. So now we're going to make a find location public int find location. This is going to be k key and v value. And assuming we return -1 if it's not found, but there always should be a value. I mean, we're finding location where it should go. Okay, so we're going to find that location. So here's how we're going to do a sequential sort. If the sort type is ascending keys, oops, sorry, sort, capital S, sort type dot ascending keys. And you can do the descending values one. So this is called a sequential search. We're going to start k at 0. And we're going to go through the whole vector while k is less than keys dot size. But we're going to stop, because we're also going to check and keys dot get of k. So we're going to look at the kth key and check how it compared to our key. Sorry, key, right? We're going to check the comparison of that with a key. And as long as that's less than 0, that means the key that we're currently looking at comes before the key that we're trying to find the location to insert into. Are you with me so far? Did I lose anybody? So again, it's like we're going to insert this new, like the all is gone here, right? And in this case, we're sorting. This is not good because we want to use. If they were sorted by ascending keys, right, it would look like this. And if we're inserting like the word and in here, right, initially, if you compare a to and, if you say a dot compared to and, is that going to be positive, negative, or 0? We're adding and 300. So keys dot get of k. So when k is 0, keys dot get of k is the little a, right? And little a dot compared to a and d should be less than 0, right? It means little a comes before a and d, right? In other words, this key is smaller than the key that we're trying to find the location to put in. As long as that's the case, what do? We just add 1 to k. We just, okay, let's keep going. Eventually, we're either going to run out of vector, or we're going to find a key that's bigger than the one that we're trying to insert, and that's the location that we want to use. That's where we want to put it, right? And luckily, the vector has that ability to insert, like ours has done. So all we have to do at that point is return k. Else, or as Anthony says, you don't need to use else. In this case, it might not be a bad idea. This is your challenge. Where now you figure out, well, how are you going to do this for descending values? It's the same idea, but you're going to be checking the values, and the compared to has to get smaller. That you want to keep going down, because originally the first value you look at is going to be a big number, right? And the value you're going to try to insert is going to be smaller, and you're going to keep going down until you find the first value that's bigger than the one you're trying to insert. And insert it at that point. It's not that hard. Should we just finish it? Oh. Okay, we should just finish it. So else, this means, for now, descending keys, descending values, sorry. So copy the same code again. And now we're going to, key size, value size is the same, right? But now we're going to see, we're going to check, wait a second, did I mess something up here? Wait, no, the keys is the vector. Yes, we're going to look at values, right? Values.getK. And we're going to compare this to the value pair that we're looking at, right? And if that's greater than 0, that means keep going, right? That means we haven't gone far enough, right? If the value that we're looking at is bigger than the one we're trying to insert, again, we're trying to add all here, right? Well, 300, that first value in the list, is bigger than 55, right? That's the case where this is 300 and this is 55. It's going to be greater than 0, right? Keep going. You're not ready to insert just yet, right? Keep going until you get to the end, right? And at that point, or you find the place where it crosses over and just return that value k. So that's your find location. And I think this should actually work. As long as you don't like, for the constructor, do you have to send the super the values in the key? No, you shouldn't. This should just be super. Are you getting an error? Wait a second. Let me get. I think I can answer that question once this actually compiles. There. Okay, it compiles. Yeah. So Jason, your question was, do you have to pass the key values to the constructor? You mean like k, like this? Do you have to say like kv here? Yeah, but that would be an example of, I think, that would make it an adapter class. This is inheritance. We're actually this is just getting passed right up. This k here that satisfies these additional conditions is going to be the same k that we're using here. But what it's saying is whatever k qualifies that's being comparable, and whatever v that qualifies here that's comparable, as long as those are both comparable, you're going to make an easy dictionary of kv to start off with, and then you're going to override the add method so it does what you want. So this should work. Did it work? It should work. It better work. It must work. So can we see if it works? Has everyone got that? Should we try it out? The key is we could try it out here with this easy sorted dictionary, with this test driver. Just that when we want to create it, we're going to have to say it's a, what do we call this? sort type dot, let's start with ascending keys. So we're going back to our test driver now, and I should have just, let me just revert. You should always, don't do what I do. You should always save what works before you trash it with something that may not work. So it should be something like that. And sort type is not found. Anthony. I have to import, but wait, I'm right in the same place, right? What do you mean?
So inside the dictionary,
I have to do, I have to import enums or what? No? What do I have to import? Uh-huh. Wait, what? Oh, you mean in the application I have to do that? Yeah, right up here I have to do that? Right up here. Okay. Import easy. So it's not visible is what you're saying, because it's embedded in the other class. Okay. Import easy sorted dictionary dot sort type, which you wouldn't have to do if you did it my way. Uh-huh. Wait, it's still not, wait, what's the problem here? Still can't find sort type. I thought it was public. It is public. Anthony, what's going on? Why can't it find it? Glad it's not my fault this time. We're waiting, Anthony. Should we revert back to the tried and true method? Is there a solution?
Yeah.
Sorry? It is public. It isn't mine. It's public here. Public static enums sort type. I don't have any experience working with enums. I try to avoid them. I use them a little bit here and there when I have to. If you comment that out, that won't work. I think for the sake of the demo, I'm going to revert mine. Why don't you all wait and see if Anthony comes up with a solution? Because it would be cooler to use something new like the enum. But I'm going to comment that out, and I'm going to make this a private int. And I'm going to make these these constants like we had before. It's not that big of a deal. And then we're going to change this to int. And then I'm going to delete the sort type in the add method. Reference to sort type is going to be removed. So that should hopefully, oh, there's another one here. Find location, remove it there as well. That should now compile. And then here, we're just going to say not sort type dot ascending keys, but easy sorted, oops, sorted dictionary dot ascending keys. Now which? Oh yeah, then we need another overloaded display method, yada, yada, yada. So let's well, didn't I make one of these easy? So let's make this displaying an easy sorted dictionary. Sorry? You found a way to make it work with an enum? Okay. Oh, that's a good idea. If you make a separate class then, right? Yeah. Yeah, so the what I did was I made another version of the, let me see here, close here, we're getting close, constructor and easy dictionary, types, no arguments. Oh, wait, what? Oh, it's not an easy dictionary, it's an easy sorted dictionary. Okay, compiles. The moment of truth is at hand. Will they be sorted? And go back to the top here. Curly, Jack, Steve, Tina is sorted, right? Yeah. Okay, now can we do it in descending values? That would be the case. That would be the Jack would come first because 1111 should be smaller than all the other numbers, right? So we're going to say descending values. Cross your fingers. This works. We're going to be rich. Ta-da. Oh yeah, Steve comes first because 8 is bigger than all the other ones, right? See? 888, 555, 333, 111. You can't subclass, but we're not subclassing it. That's important. That's embedding it, but also it's subclassing. It's compositioning. I don't know. Yeah. Okay. All right. Okay. Cool. Thank you for checking that out. So the word is better to make the enum a separate class And then that would actually work okay too. Well, I hope you found that entertaining. Question? Yes, it's all recorded. Sorry? Pardon me? Wait. Yes. Yeah. You said it was an error. Yeah, that has to happen. That has happened a couple times, but normally I get them from this semester. Yeah. If you see anything weird, let me know. Sometimes I overlook things.